So I started class by not talking. And I would show them the slides. I would do the pages right here. I'd already made them. Oh, here they are. And I would just do this. This is what I was doing for my 8 o'clock class this morning. I wouldn't say anything. And then I'd have any questions. Do you know how long it was before somebody said something? Anybody want to take a guess?
When it was
30
time.
minutes.
35 minutes.
I was close.
Before a student finally said, "Are you okay?" And I said, I typed in of course, they didn't ask me. They did it in the message thing. They said, "Are you okay?" And I said, "Yes, I'm fine. Why do you ask?" I typed that in. "You're not talking." I said, and I typed in, I said, "How does it feel?" And all of them went, "Oh, I see what you're doing now." They started talking. So I thought that was interesting this morning. I've done that. I've done that in several classes before because they're just weaned on a pickle. They won't talk. They just, and I refuse to have a class like that. I refuse to. Anyway, so here's the problem. 4/5 x plus 1/10 x minus 5. Now, this problem you cannot solve. Why? Because it doesn't have an equal sign. All right, this is not an equation. This is what we call it's not an equation, it's an expression. Expression. An expression doesn't have a what? It doesn't have an equal sign, and it usually means that you're going to simplify, not solve. Okay, so when you don't have a equation, you've got a expression, and the expression means that you need to simplify it. So I've got to get a common denominator because these two right here are like terms because they got an x. These are like terms. So you're going to have to get a common denominator. And 5 will go into 10 2 times. 2 times 4 is 8. 10 will go into 10 one time. 1 times 1 is 1. And your final answer is 9/10 x minus 5. I have found that the problem students have with this problem is they try to solve it. And you can't solve it because it doesn't have an equal sign. So I would suggest, and I don't mean this in a sarcastic way, read the directions because the directions will tell you to combine like terms or simplify. It's not going to say solve. Okay. So that should be the answer to that question, which it is. And of course, if you want another question like it, you just hit similar. We'll do that one for good measure, but I'm not gonna. I'm just gonna do it real quick. 2/3 x. 2/3 x plus 1/6 x minus 8. Common denominator. 6, 6. 3 will go into 6. 2 times 2 is 4. 6 will go into 6. 1 times 1 is 1. So your answer is 5/6 x minus 8. Combine like terms. Alrighty, next. Let's see, 6.5, 23, 25, and 47. So this one goes first. 6.5, 23/6. First of all, is it a test question? Oh yeah, it's a test question. -5 less than equal to x less than or equal to 3. Draw a number line. And let's read the directions, because the directions might say integer, and let's look and see. Okay, x is a real number. Now, I'm going to write down integer in red, and that means a whole number. Real numbers means decimals, whole, decimal, whole with decimals and fractions.
Can we see the whiteboard?
I'm sorry.
Thank you.
And fractions. So integers, you use dots. Real numbers, you use the shade. Okay. So, and we'll probably see one of those integer problems with the next two questions. I guarantee you probably one of them is an integer problem. So this one, you don't have to solve anything because x is by itself. 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6, and 7. Okay, so we know we got closed circles, and I'm not going to go into that because I showed you why we have closed circles. So we got a closed circle at 3. And we got a closed circle at -5. What numbers are less than 3 and more than -5? Well, that's in the center. So you shade, since it says real numbers. Real numbers means you shade. And that's your answer. So let's write it in set builder notation. Set builder notation. That'd be a big brace, X such that, and a big brace, and then you just put your answer in here. I'm going to do the answer in different colors so you know that all you do is write this down like that, and then put your answer right here. So here's our answer. -5. That's all you do for set builder notation. For interval notation, you just read the number line. And all of us read from left to right. Even though some of y'all try to read right to left and diagonally when you get to math. I don't know why you do that. Some of y'all do, teach the students in general, not to anybody in here. But bracket, -5, comma, bracket, 3. And that's interval notation. So one of the three is what they're going to ask for on a test. And let's see, I'm going to pull in my handy dandy whiteboard. And it's not that one. And it's not this one. Why isn't it those two? Somebody tell me why it's not alpha and delta.
Open circle.
Good job, Miss Cersei. I don't know what I'm going to do with you. She's on the ball. It's got open circle. And I told you at the beginning of 6.5 that you had to write down those 4 inequalities and what they stood for. And these two stand for closed circles. And this one's not it because it's going opposite direction. So it has to be B. And you feel good about yourself. Is that a test question? Yes. Is that a standardized test question? You better believe it. They love to ask these on test, standardized test. So if you can't do this one, that means you're pretty much a failure and that you should probably just give it up. Right, Miss Hatton?
Yep, I was about to.
I hear you. All right.
I had a guy explain it to me that if you lose yardage on a football field, the circles are closed. If you gain yardage, the circles are open.
I don't believe I would necessarily agree with that. Because basically the open circle basically means exclusive. And that means that I can't use whatever number that circle is on. Let's say it's on 4. Then I can't use 4. Okay, I can't use 4 in the equation, but I can use 5. Let's do 5 right here. I can use 5 or I can use 3 based on whatever my inequality says. So the inequality can go to the right or to the left. I wouldn't necessarily say, now I would agree that the negative yardage means left on a number line, and positive yardage means that you're going right on a number line. I would agree with that, but I wouldn't necessarily agree with the football analogy with the open and closed circle. I'd have to think about that a little bit more.
Well, that's what he was talking about. The negative yardage is negative, and then the positive yardage is positive.
Yeah, I guess you could. Now that I agree with, but I don't think you can apply that to these 4 things, because you never know which way is. See, I could rewrite, and that's what I'm trying to get to y'all. Just because x is on the right-hand side, x is greater than -2. Oops, I'm sorry. Okay, x is greater than -2, or -2 is less than x. And then I could change this to x is greater than -2. Okay, so it really, I don't like to, I don't know. I guess I'm just, I never heard that before, and I guess I'm just trying to let's see, 0, 1, 2, -1, -2. That's going to be a closed circle. And what numbers are greater? But see, I could easily do this. And that's going to be to the left. So I guess I don't know. I don't see. This is a closed circle, but it's going to the left. You got to be careful. And that's negative infinity. I could say x is greater than 1. And that's the open circle. And it's going to the right. Because all the numbers that are greater, oops, I'm sorry. pull that up. X is greater than 1. There's the X is greater than 1. And the numbers that are greater than 1 goes to the right. So I don't know. I'd be careful with that if I was you, Miss Cersei. Okay. I always just tell students to graph it. If you graph it on the number line, you won't go wrong. If you try to do it in your head, chances are you're going to end up in trouble. All right, let's try this one. 6.5, 47/9. I figured I would at least get an integer. Nope, no integers. I'll have to find one in your homework. The following graph shows the total widget production in billions in the United States, blah, 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 blah. In which years was the number of widgets produced, A, greater than 8.8? So what numbers are greater than 8.8? Well, this one, 11.4, 11.1, 10.2, and 10.6. So that's 6, 7, 9, and 12. 6, 7, 9, and 12. Now, why didn't I pick 8.8 and 8.8? Why didn't I pick that? Because you can't use 8.8. That doesn't work. That's why you don't have an equal sign here. So I can't include 2005 and 2008 because it says greater than, not greater than or equal to. So we check it and we feel good about ourselves. All right. Less than or equal to 8.8. Okay, this one. So 5, 8, 10, 11. 5, 8, 10, 11. Greater than or equal to 10.5. Well, 10.5, 1, 6, 7, and 12. 6, 7, and 12. This is a good standardized test question. They love to put these graphs on the test because it technically kills two birds with one stone. The math, and then can you read a bar graph? All right, less than 7.1. Well, looks like just that one. 2011. And that should be it. That's a good standardized test question. Okay, so that takes care of the questions that were sent. Let's see, did we go over that one? This is 6.5. I'm trying to find an integer. I might have to go to the homework. 6.5, 57, 12. Let's see if this is an integer. No, we already did that one. We did that one last time. Okay, so I'm going to go find one. Let's go to your handy dandy homework. Oh, the things I do for y'all. Should just go over new material, but I tried.
We all appreciate it.
Yeah, I know you do. Those that talk. Okay.
I was about to say the same thing.
6.5. Let's see, assignments. 6.5. And okay. Look for the directions. It says integer. There we go. All right, and that's a good test question. I'm glad I found this one. So I'm gonna put this one.
You have a work email.
Go ahead and write it down.
Coming in on secure
Just
channel.
ignore the number lines. Don't even write that. Just write this down, and I want you to solve it. I'm gonna write it down for you so you can see it. That's gonna be 7 times x plus 1 minus 6 is less than or equal to 5x plus 9. All right, I'm going to take my handy dandy phone out, and I'm going to give you 2 minutes. Now, you can solve it, or if you just want to stop after you solve it, that's fine. If you want to solve it and graph it and put it in set builder notation and interval notation, go ahead. I'm going to give you 2 minutes. Do whatever you want. And of course, if you can't finish it in 2 minutes, we're all going to make fun of you in class. You know that's not true because I don't know whether you've done it or not. It's a joke. We're going to make fun of Miss Hatton anyway.
No.
Yeah, we're going to. We talked about it before you got here.
Oh, I'm glad y'all was thinking about me.
Yeah, we talk about you when you're not here. And then if you're not here, we talk about Miss Cersei.
We're always here.
Okay, that's been about 2 minutes. So if you hadn't finished yet, then we're making fun of you mentally. All right, so distribute 7. That's going to give me 7x plus 7 minus 6. 7 minus 6 is 1. This is my smallest bucket, so I'm going to move it across the river. Move this across the river. And I get 2x is less than or equal to 8. X is less than or equal to 4. Draw it on the number line.
Priority 1 message coming in on secured channel.
Why, it's blowing up my phone. Okay, now everything's the same on this, except, let's take our handy dandy highlighter out. And I'm gonna make it a BA highlighter. I've already made it. Okay, we're gonna take this red highlighter and we're gonna highlight that word right there, integer. They do this on standardized tests too. Okay. When it says integer, you need to mark through that, and you need to say, mark through it and say whole numbers. I'm writing with a mouse, so whole numbers. And that does away with your highlighter shade. You have to actually put dots on the numbers because you can't include what's between the numbers, decimals and what? Fractions. So you have to do dots. So here's what we're going to do. First, I'm going to get rid of this. And I know what numbers are less than 4. Well, those numbers are everything to the left of 4. Does it include 4? Yes or no? That means I want y'all to talk to me.
Yes, yes.
Thank you. So here we go. I'm going to use an orange highlighter. And I'm going to put a 4, 3, 2, 1, 0. And I can't say infinity because infinity includes what? Fractions and what? Decimals. So instead of infinity, I'm going to put 3 dots in a row right here. And that means all numbers, all whole numbers to negative infinity. Put a negative right there if you need to. Okay, so here we go. My set builder notation is going to be X such that blank braces. And then put this in there, and I'm just going to do that in a different color so you know that's all I'm doing is plugging that in right there. So there's my set builder notation. And then my interval notation, we read from left to right. So negative whole number infinity to 4. And that is interval notation. So standardized test, or my test, will ask for one of these answers. And you've got to, when you're dealing with the word integer, integer is the same thing as whole numbers, which means you cannot use fractions or decimals. So that takes away the areas between the hash marks. So you cannot use fractions or decimals, so you have to use these dots and these dots right here to say all the whole numbers from negative infinity to 4 will fit in this equation. So I can plug in a 0 right here. And if I plug in 0, I'm going to get a true statement. I can plug in negative 4. I can plug in negative 100. I cannot plug in 5. 5 will not work. Okay. Now I need you to make sure you understand that question and why it's different from the shaded regions. Okay, let me show you. This is a shade. Shade goes with real numbers. Dots go with integers. So let's look at the question and see which one it is. Well, let's see which one it's not. So I'm going to take my handy dandy highlighter. Oops, sorry. Which one is it not? Well, it's not these two because those are shades. Those are real numbers. Those include whole numbers, fractions, and decimals. And this is not right because this is greater than. So it's got to be delta. and you should feel good about yourself. Y'all got that one? Yeah, Hubert, we're good. Good. Thank you for your interaction.
Can you work another one?
I'll be glad to.
Yeah.
Y'all just stalling because y'all don't want to go over graphing. I know what y'all are doing.
I think
we're
I get
worried about
crossed up on
test.
my
You think what?
I get crossed up when you have to bring the opposite number, like to get rid of. Like if it's a negative, I put a positive, and it's messing up my math.
Yeah, just show me what you're talking about because I don't know what you're talking about. I'm going to go to study plan. 6.5. Study plan. I go to study plan because sometimes the teachers, they don't put enough questions on the homework. So sometimes I can go to study plan and pull out a better question out of the study plan. That one's too easy. See if I can find one like we just did. There we go. Wait a minute, hold on. Yeah. Go ahead and do that one. I'll write it down for you. It's kind of like the one we just did. 9 times x plus 7 minus 42 is less than, equal to, 7x plus 5. All right, we'll go give you 2 minutes.
Gmail.
Okay, that's close. So let's go to it. So that's going to be 9x plus 63 minus 42 less than or equal to 7x plus 5. 9x. 63 minus 42 is like what? 21? Somebody needs to check my math there.
Yes.
It is.
7x is my smallest bucket. So I'm going to take it across the river. 21, take it across the river. 7x minus 2x is, 9 minus 7x is 2x. And 5 minus 21 is negative 16. So there's my braces. X such that, and you just plug that number back in here. So that's x less than or equal to negative 8. Number line. Negative, positive infinity, negative infinity. Now, since this is integers, I'm going to put my 3 dots right here. And 3 dots here. Oops, sorry. And we're going to do 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 8. Oh, shoot. I went the wrong way. I thought it was greater than. Okay, so anyway, that dot, that negative 9, and negative 10. Remember, we can't use negative infinity. So negative dot, dot, dot infinity, meaning negative whole numbers, all the way up to negative 8. And we do include 8, but we can't touch infinity. So this is set builder notation. This is interval notation. And this is the graph. Now, I did see one question I want to go over just for good measure. Let's take this one out. You know it's not this one, and you know it's not this one because it says integers. And that means it's either this one or this one. And it's not this one because this is greater than. It's got to be A. So click on A and check answer. This question I saw, this question is the one, and I gave you one like it in the notes. And I told you that this is the only time you can't manipulate the X and make it positive. The only thing you can do is divide through by negative. And when we divide through by negative, you have to flip everything. I don't teach negative exponents. I teach students to keep the variable positive, and it helps students out tremendously because they don't have to unless they need to. Okay, so in this case we've got negative, or 4 is greater than negative x greater than or equal to 0. See, in this case I cannot move the X. I can't move the X to make it positive. I usually do that with the smallest bucket. But in this case, since X is by itself, I can't really move it to make it positive like I did in the last equation. I took the 5 right here. I took the 7 across to make my X positive. Okay?
Priority one
I
message
can't
coming in
move.
on secured
I
channel.
can't move that X. So I'm going to have to go back to the old ritual. If you divide or multiply an inequality, by a negative, it flips the inequality. Now, the reason I don't teach this very much is because students forget to do it. And that's why if I give you 9 problems, 10 problems, and 9 of them you can move the X, I would much rather you do that than try to remember this. And just remember this for that one problem that you can't manipulate. So I'm going to divide by -1. And that's going to flip these inequalities. So my answer is going to be -4 less than X less than or equal to 0. And I showed y'all that when we did the regular, just the regular inequality. I said this is the one that you can't get away from the law. And that's this law right here. So it did say integer. So we're going to draw a number line. Dot, dot, dot. Negative, dot, dot, dot. And this is -4. And this is 0. So we get a bracket or a closed circuit or closed circle there. And we have an open circle here. And there is, let's see, -1, -2, -3. And we put a dot here, and a dot here, and a dot here. So the answer is parentheses, -4, comma, 0, bracket. That's in interval notation. Sorry, hold on. That's in interval notation. And set builder notation, I'm just going to put this. I'm not even going to rewrite it. I'm going to put a brace around it. And this, and X such that, and a brace. There. There's set builder notation. So we've got set builder notation. We've got interval notation. And we've got a graph of it. And that's it. And I'm going to let y'all go today. So y'all don't have any new material. Y'all did good. Y'all stalled me out. So y'all don't have any new material to go over. Y'all did that on purpose, didn't you?
Nope.
Yeah, you did.
Not really.
Okay, so now that means when y'all come back Monday, we're going to start on 6.6. I need y'all to read over that handout. I need you to print it out and bring it to class. I've already done the roll. Mr. Brown, you might get an email that says you were absent this week, but you wasn't. I sent an email to student records to count you present for today. And it might take today or Monday before they get to do it. But if you get an email today or this afternoon or this weekend that says you were absent, just ignore it, okay? All right, anybody else got anything? I'm going to cut a shutter down and I'm going to cut off the recorder. Y'all have a good weekend.